Anybody have a question they want to ask about the metaphors of adding or subtracting integers that were on the quiz? You either got them right or you figured out what you did wrong? We're okay, we don't need to talk about any of them? Okay. The exams were returned to my office sometime Thursday, and I wasn't there, but I found them this morning when I got back. So we'll get right on them and get them back as quickly as we can. Questions from the homework anybody wants to ask about? Yes?
Was it open for us to turn it in?
Pardon?
Because I wasn't able to turn it
You couldn't find it?
in. Well, I did it. I just, it said the due date was different and I didn't know.
Yeah. The due date wasn't stuck up there until, so that's, let's see, it's, just upload it right now where it's at, and if you're a little bit late, put a little thing in there saying it wasn't in your description with your name, but it wasn't available, and we won't penalize anybody. Any other questions? Anything from the concepts on the homework that? So Kinsey prepared you well to go home and do it? Okay. Just a point I want to make. So many students, when they get to algebra, they memorize this thing, you only add or subtract like terms. But when you're using algebra blocks, it's obvious that you don't add a little bar x with a x squared because they're not even the same critters. What do you call it? The same animal, the same thing. It doesn't make any sense to add a little bar to a little unit or to a x squared, just like it doesn't make sense to add teaspoons or tablespoons together. And doing the concrete is something that students really need. Even the good students need it. I think it's helpful to give every student, even the supposedly the gifted ones, an opportunity to do that. One of the questions on your homework asked or had you do some analysis of some student arithmetic. There was Aaron and Ashley that you tried to identify where they made their mistakes. The question I want to ask you is, if this is a math content course, why would we bother about the method as opposed to your methods course that everybody's going to have to take Ed 442? And why would we do something like analyzing student work in a content course? Wouldn't it fit better in a methods course? Anybody have any ideas about that? Why would we stick it in a content course? What does it have to do with content rather than, methods? Yeah.
Sometimes it helps to see if you're like to know if your students are grasping what you're teaching. Like it helps if they understand what you're supposed to do. It helps them.
Yeah, it's something that you definitely want your students, or you want to be able to do, but But the question I'm saying is, why put it into a content course? Christy?
I think it helps like us have more of a depth of understanding too, and we're able to look at a problem and see what they're doing. It helps us to understand how and why to do the content ourselves.
It really is tied to, if we know the content, we're going to be able to make those decisions better. Did you, Katie, that same thing? Yeah. So you can't really separate it from the methods because you've got to know well how to add and subtract whole numbers, fractions, integers, decimals, if you're going to be able to look at students and see what might they be doing to add and subtract, and why might those errors be there. So just give you a little bit warning about you will be doing more of this, considerably more of it in your methods course, I'm assuming, but it is part of a methods or a content course as well. What I'd like to talk about right now is estimation and mental math. And before we begin this, there was a, I think, supposed to be, Ben, would you estimate in real life? Wasn't there a question? How come I can't see it? Was it on last night's homework or the ones before that? Well, we'll just ask it. When would you want to estimate an answer in real life? Yeah, okay. Why would you do that? I mean, why would you want to be able to estimate?
Because you're not going to sit there and know exactly how much money you have.
Okay, so you can do it all mentally, so you don't have to take your calculator to get the exact. And why do you care? I mean, why are you even calculating, let alone estimating?
To make sure I have enough money for
Yeah.
what I'm trying to buy.
Some people, it doesn't bother to get up there and be short of money and, oh, just keep this back or whatever. But some people it bothers that they're there. There was a hand.
Just grocery shopping also. I seem to buy a lot of food at times, and if it's on sale, sometimes it doesn't ring in, so I just get an estimate as I'm putting it on, and I kind of go up or down, so that if they say it's $10 more, I can say right there, wait a minute, and they can check and say, oh, those things didn't ring in, $3 off, and that's a big deal. So it just makes it easier. It's an extra step. I don't have to go back later.
But the cash registers, they never make mistakes, do they? Okay, yeah.
Like my sister, she just had her mission farewell yesterday, and I asked her how many people were there, so she gave me an estimate.
Oh. Yeah, that estimates of crowd sizes is, yeah, how's that done? That's kind of interesting too. How do they estimate crowd? Yeah.
Oh, I was thinking like we were going on a road trip, we would what would be gas?
All right, how far will my gas tank last? What approximately, where do I? You don't need to know exactly. In fact, if you went exactly, you may run out, right? Because your gas mileage may be less or whatever. But that would be, in fact, when you're going on a trip of any kind, you'd say, I wonder what this trip is going to cost me. Well, if hotels are $70 a night or whatever, you decide you can get them for, and we're going to be 5 nights, the hotels are going to be this much, and you can actually get your total in your head, right? Especially if you overestimate, so you make sure you have enough money when you take off, right? Overestimate the cost. Okay, lots and lots of uses. Today we're going to talk about 2 kinds of things. We're going to talk about estimation, and we're going to talk about mental math as they go with addition and subtraction. This PowerPoint is available, so anything you see on the PowerPoint you don't need to write down, but if there's some things that you learned that aren't there, you might add those to your notes. But 2 objectives today. The first one is, how do you do mental math to get exact answers? And the second one is, how do you use mental math to get approximate answers. So we're going to be getting estimates, and we're also going to be getting exact answers, and both of them will use mental math. We want to be able to do this with no paper and pencil, with no calculator, just using our heads. So 2 different things we're going to do today. We'll begin with the exact answers, and the first strategy we're going to talk about is the adjustment strategy. It has some other names, sometimes called the compensation, or I've heard it called the near 10 strategy, and it works for both addition and subtraction. Here's how it works. You want to adjust the numbers, hence the number adjust, or the name adjustment, being added or subtracted so that the resulting 2 numbers can more easily be computed mentally. Now keep in mind we're after exact answers here, we're not after estimates. Okay, the key is to make sure to adjust the numbers in a way so that your sum or difference gets preserved. Okay, here's an example. If we're going to add 47 with 36, the standard algorithm would require that we start with the ones place, add the 7 and the 6, get a 13, and then we would, using the old language, we would carry the 10 to the other column, or in our language, we would exchange a 10 to the 10's place. Okay? Doing this in your head requires you hold on to the 10's left over from adding the 1's and then adding them to the 10's, all the while remembering how many 1's you had in your head. This is not too difficult mentally until you get add-ins that are 3 digits or more, and then you're trying to see, now what did I have in the 1's place? So I'm clear over here on the hundreds now. You see what I'm saying? So it's all starting to, depending on how your brain works, some people it works very well, and others they have a real hard time. So what could we do? Well, 47 plus 36, we could approach it like this. We could adjust the 47 and turn it into a 50. Okay? 47 is near 50, which is a multiple of 10, hence the other name that we sometimes call it the near 10 strategy. 47 was near the multiple of 10 called 50. Now why would we do that? Because 50 is much more easily added to 36 than 47 is, right? Don't you agree? However, by adding 3 to the 47, we end up getting a sum that's 3 more than what we're really after. Does everybody follow it? We've got 47 plus 36, and we've changed this to a 50. But if I go 50 plus 36, my answer is going to be wrong. It will be what? 3 too much. So what do I need to do? I need to adjust the 36. How? Make it a 33. So what's going on here? This one I went plus 3, right? This one I went minus 3, and the 2 compensate for each other, right? And we end up getting what for our answer? 83. Which is the very same answer as we would have got had we done this standard algorithm, right? Does everybody see what? Okay. Which problem is easier to add in our head? This problem or this problem? The bottom one. Everybody would agree, right? Well, if it is, and it's easier to add these, this is an easy process. Add 3 to this, subtract 3 from that. You get the same answer because we adjusted these add-ins so we could get the same answer, or we changed this one to compensate for this by taking this to a near 10. See the names, near 10, compensation, and adjustment. All right. Now some of you would say, well, wait a minute. We take the 47 plus 36. And you could say 36 is near 40, so we adjust this to 40. Well, what would we have to do here? Subtract 4, making it 43. And we get 83. Isn't this one easier to do than this one? So now the question is, which is easier, this one or this one? I don't know that there is a easier one, is it? They're both easy, aren't they? Okay. Okay. Does everybody see how you're adjusting when you are adding? Let's look at subtraction. The subtraction adjustment works in a similar fashion. Let's take 62 minus 37. Let's adjust the 37 to be what? 40, the near 10. It's nearest to that power, or that multiple of 10. So now our new problem is what? Well, if I subtract 40 from 62, I'm going to end up with a difference that is what? I've taken away 3 more than I should have, right? So how do I compensate or adjust for that? Add. So make this 65. Does everybody see what we're doing? Since I was taking away 3 more than I really should have, if I start out with 3 more, it'll all come out in the wash, exactly the same amount. And what's the answer? 65 minus 40 is 15. Is this the answer to 15? 25, my goodness. Is it a Monday or what? 25. Is this the same answer up here? Yes. Why? Because I adjusted it to compensate properly. Okay? All right. Let's look at the same problem, 62 minus 37. This time we're going to take the near 10 to the nearest one here is 60. But if I'm starting out with 2 less than I normally would, and I subtract 37 from a number that's smaller, the difference is going to be what? Smaller than it should be, right? So I should take away what? Who knows how to adjust this? So make this 35. Is that what you're saying? Anybody agree? Notice over here we added 3 and subtracted 3. Here we what? We added 4 and added 4. What did we do here? We added 3 and added 3. So add 2 and, subtract 2. We would subtracted 2 and subtract 2, right? What's the answer here? $25, right? So these all should have an answer of 25. Who's got a question? Kelly, did you have a?
I thought we were adding, so never mind. I exclude my point. I thought we were adding, so
Oh.
it's like, it doesn't make sense to subtract.
We're subtracting.
Okay, that makes more sense.
Okay. Oh, what would you say is the easiest here? This problem or this problem?
The 65 minus 40.
I think most people would agree with this, right? Although this isn't real difficult in your head because you're taking it from a nice multiple of 10. It's certain, this one's certainly easier than this one, right? But depending on how you compensate, you might get one that's a little easier than another way. They're both correct compensation methods or adjustment methods, but one might give you a easier mental problem than the other. Okay? Okay. We've already answered that. Looking at it even another way. If I were to make a number line and put 62 on it and put 37 on it, 62 minus 37 represents what? What's the idea on the number line? The distance between the two numbers, right? Everybody agree with that? So, when we do this adjustment, we move this to 65. What have we done? We've moved this up 3, right? To 65. If I want to keep the distance between the two numbers the same, keep the same answer, what have I got to do to this? Add 3 to it as well. Does that make sense? So my new problem is 65 minus 40, and that should be the very same as this one because the distance between them is the same. Does that make sense? Now you'll notice that with addition we did what? Add 3 and subtract 3. That makes sense because you're moving one add end bigger, so you better make the other one smaller or you're going to get the wrong answer. But when we're subtracting, what do? We move them both the same way, the same amount, and that's because on a number line, you want to keep the distance the same. So if we do this one, change this to 60, we're going to go down 2, right? We better go down 2 here as well to keep that distance the same. So it would be 60 minus 35. Does everybody see how the number line model helps to see why they both go the same direction in subtraction? Because we're after a difference. Okay. So the adjustment, sometimes called the near 10 or compensation. What I'd like you to do is on a piece of scratch paper, use those strategies to make some, to get your sums or differences. Okay? Over that, I'm adding two numbers together to make it, to get two numbers that are easier. I moved one of them to the nearest 10. When I did that, I added 3 more, which is going to give my sum 3 too much. So to compensate for that, I dropped this one the same amount. I went up 3 and down 3, but the resulting two numbers are easier to add in my head. Does that make sense?
No. I mean, the concept makes sense, but because the other ones you add 3 and that one you subtract 2 on both sides, but that one you did plus 1.
I did plus 3 minus 3.
Yeah.
Why do you do that for addition?
Yeah.
Because if you're adding two numbers and I add one, or I add something to this, the sum of the numbers is going to be too big unless I take some off of this number to compensate for it. That's why I took 3 off, because I put 3 on. Does that make sense?
Kind of.
The sum will be the same of both of these, but this one's easier to add in my head. Okay? If you use the number line model for that, let me see if that helps. You would take an arrow, this would be 0. My first arrow would be 47 long. So take us up to 47. And then from there, the arrow would be 36 long. which would put me at 83. That plus that. Well, if I make one arrow 50, 3 longer than it was before, then to get to the same answer, the next arrow's got to be 3 shorter.
That makes more sense.
The arrow diagram help? Okay. Who can share what they did with the first one? Yeah.
I, for 84, the 57 plus 84, I plus 3 to 57 to make it 60, and then I subtracted 3 to the 84 to make it 81.
So you added 60 and
81.
81, and that's
141.
141. That's easier than doing this other problem, right? Okay. How about the next one? Jessica, do you want to do that one?
I added 3 to the 286, and then I subtracted 3 from the 347 from the 86.
You did what now?
For the, to the 286, I added 3, or added 4, sorry.
4.
I added 4, and then I subtracted 4 from the 347.
So the adding 4 to the first one, you got 290, and then subtracting 4, you got 343. And you added those. How many of you think that's easier than adding that one? Yes? Did anybody do it any differently?
I added 3 to 347, and then subtracted 3 from 286.
So that gave us 350, and subtracted 3 from 286, which gave us 283. That might be easier, but I don't know. I think we could argue. Did anybody do it any differently?
I added 14 to 286.
You added 14. Is that hard to do? No, and that gave you what?
300.
300, but then what did you have to do to compensate? Subtract 14 from the 347, which is 333. Those should all give us the exact same answer, right? Which one's the easiest, you think?
Well, I think the bottom one would be the easiest, but you'd have to like think to get it.
You've got to be able to see that adding 14 will get you to 300. Okay? So there's more than one way to do this and do it accurately and still do it mentally. Although this is probably, the numbers that result from this are a little bit easier to do. Okay, anybody for 83 minus 48? Rachel?
Subtracted 3 from each one to make it 80 minus 45.
80 minus 45.
Although after I did that, I thought, well, it probably would have been even easier to go the other way, so that I didn't have a 0 minus 5.
Did anybody go the other way? What did you do?
I subtracted 2 from 48 and added 2 to 83.
So what are the numbers that are, this becomes
85.
85, and the other one? 50. So what did you do to them?
I added 2 to 83, and then I subtracted 2 to 48.
You did? You added 2 to 48.
No, I subtracted, well, I added, sorry. It's a negative 2 that I added, negative 48.
Okay. I see what you're doing. Yeah. You're thinking about it a little bit different than what I showed. Do both of these result in the same answer? Which one's the easiest? Probably this one. Okay. How about the last one there? Nobody got the last one? What's that?
I added 2 to the 168 and made it 170. And then
Okay.
then added 2 to the other side.
And made it
308.
308. Is that one a difficult one? It's easier than the one that's up there, I think. Anybody else do differently?
I subtracted 6 from 306.
So you subtracted 6 and got 300 and
Subtracted 6 from
got 166. Third one, 162, excuse me. Subtracted 6 from both of them. These should be the same answers, are they? And it should be the same as doing it with the standard algorithm. Which one's easier to do in your head, this one or this one? Got a toss up? Maybe? But these two are definitely easier than that one, I think. Okay. There's just a couple of different ways that you could do those. The answers that... Okay. Take a moment and summarize the adjustment strategy for both addition and subtraction in your textbook. And you should probably include some examples with your explanation. When you're adding two numbers, how do you adjust? When you're subtracting two numbers, how do you adjust?
I have a question. How would you feel if it was like a negative and a positive?
What do you mean?
So like, I was looking at the homework and there's a problem that's a negative and minus a positive.
So if we had a 28 plus a negative 13, is that what you're talking about, or?
What if, I don't know.
I could add 2 to this to make it a 30, but then since I'm adding, I need to subtract 2, which would make that a negative 11, correct?
But I thought if you subtracted 2 from negative 13, that would make it.
Let's see here, if we add 2, we need to subtract 2. Subtract 2, that makes, yeah, you subtract 2 from negative 13, there we go. That should be the same amount, because we added 2 and subtracted 2.
But what if, sorry, I have no questions. What if it was like negative 28 plus, 15? Would you just do the same thing?
Positive something?
Yeah, just a positive number.
Positive 36.
Yeah.
If we change this to negative 30, what have we done?
Subtracted.
We've subtracted 2, so we should add 2 to this. That one is definitely easier to do in your head, right? And it should give you the same answer. Good question. All right. All right, here's another strategy besides the adjustment method. Some numbers just go better together. In other words, are more compatible than others. The compatible number strategy, sometimes called easy combinations, relies upon this fact and also the properties we've learned about for adding and subtracting numbers. For example, if I've got the problem 46 plus 18 plus 34, we could add the 46 and the 18, and you're going to have to make an exchange there, right? So that'd be 64, right? Then add that sum to 34, but it would be easier to mentally add the 46 to the this plus this to begin with, right? Why is that nicer? How is it nicer?
Because then you're getting to 2 zeros instead of just.
You're getting a multiple of 10, which is then easier to hang on to in your head. What do we get? 80. And now all we've got to do is add 80 to the 18 that's left, which is really easy to do since it ends in a 0, right? And both ways get you the same answer, but one is easier doing it mentally than the other. Okay? The properties that are involved are the associative and commutative properties. So what we're really doing in our heads is we're grouping, associating the 18 with the 34. Then we're commuting inside the parentheses, changing the order of the addends. That's the commutative property. Then we're reassociating, putting the numbers together that are compatible, and we're doing that all in our heads as we look at it. We're not thinking about associative and commutative properties, but that's what allows us to do that. Does that make sense? Okay, you try it. Okay, who's got the first one?
I think I do.
Okay, what'd you put together?
I did 18 and 12 and got, is this right? 18 and 12 and got 30.
Okay.
And then 23 plus, where'd it go? I did 29 plus 11 and got 40. And then the 23 and the 7
Okay.
and got 30, and then plus 35,
So the answer is
135.
135. Everybody see what she did there? Okay, how about the second one?
I combined 7 plus 3 to get 10, 6 plus 4 to get 10, 8 plus 12 to get 20, 6 plus 4 to get 10, and then I combine all those, which would end up being 50, and I just added the 3 plus 3.
And then there were a couple of 3s left over.
Yeah.
Okay. Is that the only way that you could have done it? You could have actually put 2 of those 3s together to make a 6, and put it together with a 4 to make a 10, even. Yeah. Lots of different ways. Okay, how about the last one?
You can put the 4 and the 1 together, and then add a 15 to it.
Ah, so 4 and 1 makes 5, and add 15. We're now to 20.
And then add the 48 and the 12.
And that makes 60. So we've got 60 and 20, right?
And add 17.
and add 17 to that, and that gives us 97. Okay. All right. Let's now talk about estimating. It's still a mental process, but we're not worried about getting an exact answer because many cases don't require an exact answer. Here's one that some of you brought up. Let's say you're in a store and you're buying 3 items that cost $1.49 and 4 items that are $3.95. You want to be certain that the $20 you brought with you will cover your purchases. No need to pull out a calculator. We'll take the $3.95 and round it to what? $4, and we're getting let's see, 4 of those items, so 4 times 4, 16, and then we're getting 3 of the $1.49. $1.49 will round to $1.50, and 3 times $1.50 is $4.50, so my $4.50 and my 16 makes $20.50, and you're going, well, something's got to go back because we're going to be over. Now, some of you are saying, yeah, but we rounded everything up. Maybe we would have enough. Well, if there's tax, we know there's not going to be enough. But you could go back and actually get the exact amount. If there were 4 of those items at $3.95, we're rounding those up 5 cents. 4 of them, that's 20 cents, right? And we're rounding the other 3 items up just 1 cent, that'd be 3 cents. So we're really only overestimating it 23 cents. We still don't have enough, right? For the $20. So you could get them more exact if you needed to. But, all right. Much of the math that we do in our everyday life is mental math. Our goal is to get as close as you can to the actual number, but still to do the math mentally. For example, if you went to add these 2 5-digit numbers, and you rounded the first one to 29,350, and the second one to 53,870, did those get rounded correctly, by the way? Is this rounded correctly from that? And is this one rounded correctly from that? Yes. And then you grab your calculator and add those 2 rounded numbers. That's not what we want. If you're going to do that, you might as well just put the original numbers into the calculator. If you've got a calculator, so what might we do? We want an estimate. We don't want an exact answer.
Round to the hundreds and the thousands?
Maybe the thousands. That would make it 54,000 and 29,000, and we could probably add those in our head. 54 and 29, and if you couldn't, you could adjust, right? Move one up to 30 and one down to 53, and then add them that way. So you could use your adjustment strategy while you're... Does everybody see what we're doing? That one's possible. Or, if you don't need to be very close, you could just say it's about 30,000 and about 53, or about 53,000, and that'll make it about 83. Right? Does everybody see what? In fact, one way of looking at it is take this 865 and put it over a year. That would mean round this to 30,000, right? 30,000 is easier. 30 is easier to add to 53 than the other way around. The important thing is, if you're estimating, is what? There's 2 things. You missed it? You better write this down. Estimation must be mental, Okay? So you've got to be doing it in your head. And the next one, you don't need to have exact answers. Now, the closer you can get, the better, but if you're not doing it mentally in your head, it's not an estimation. Here are the rules for rounding, which you learned probably in about, I don't know, 4th grade, somewhere there. You decide which place you're going to round to. If the position to the right of that spot is 5 or more, you add 1 to the digit in the position you're rounding, right? Otherwise, leave it unchanged. And then replace all the positions to the right of that position to which you're rounding with zeros. You know what I'm talking about? What about fractions or mixed numbers? If the fraction's close to a half, round it to a half, because usually you can deal with halves. If it's closest to a whole, round to that whole number. If the fraction is closest to 1 whole, round the whole number portion up 1. If the fraction is closest to 0, round it down to 0 and leave the whole number unchanged. Let's take a look about what that might entail. Many students get the terms estimation and rounding mixed up. They think rounding means estimating. No, rounding is one thing we use while we're estimating, but it's not the only thing. If we stuck rigidly to that rounding rule, we may not get the very best estimate we could get. For example, if I wanted to add these two mixed numbers, we might round the first number to 4, since 13/24 is over a half, right? What's half? 12/24, so we're just barely over a half. That would make that be 4. This is also just over a half, because half of 36 is 18, so this is just over a half. So we'd round that to 5. So then we would add 4 and 5 and get 9. However, if we look carefully, we'll see that both fractional parts of the numbers are close to a half. That's just barely over a half, and that's just barely over a half. So round those both to halves. Add the two halves together, you get 1 whole. Add the 3 and the 4, you get 7 plus the 1 whole is 8. And how does that compare with the other? 9. Well, it's not very far off. Which is the most accurate? The 8. And which was the easiest? Well, they were both easy. But if they're both easy, why not go with the one that is the closest estimate? Do you follow what I'm saying? So try and get as close as you can. If it's just as easy, do it. All right, there's just some to practice on. These are estimations now. We want answers that are close. We don't need exact on these. When you've got all your answers written down, go to the board and put one on the board. Pick the one you want. Okay, that's the very first one. If anybody did the first one differently, I'd like to see that. Okay, you took the fractions and did what with them?
Rounded.
Both of them up, because they were very close to a whole, right? Everybody okay with that one? Questions?
On the one where they're all in the line, since 23 and 45 and 52, 42 are really close, we'll round one up and one down.
I think that would be smart, yeah. Yeah. In fact, you could add the whole numbers, we'd get what? The whole number thousands, which we'd get 12,000, right? Then you could say those hundreds, I could put 300 and 300 with a 400 to make another 1,000. And then take the remaining, which is 496, is about 500, so we'd say about 13,500, and that's pretty darn close. It's a little bit over what we have, but it would be pretty close. Yeah, so get as close as you can, but make sure you're doing it mentally. Some of you having a hard time doing 290 plus 330 in your head, just make this 300 and this 300 and get 600. You're going to be pretty darn close, depending on how close you need to be. But that's probably doable in your head, and that would be better. Okay, good.